EAPCET Maths 2A probability. First one, the probability of getting exactly 2 tails in 6 tosses of a fair coin is, here a fair coin is tossed 6 times, 6 tosses. So n of is number of points in a sample space is 2 power 6. Because a coin has 2 faces, head and tail, it is tossed 6 times. So 2 into 2 into 2 into 2, so on 6 times. So 2 power 6. And n of a event is the probability of getting exactly 2 tails. Exactly 2 tails. Out of 6, exactly 2 tails. So that is 6C2. N of a is 6C2. Therefore, probability of getting exactly 2 tails in 6 tosses of a fair coin is denoted with P of A. P of A formula is N of A by N of S. N of A is 6C2 and N of S is 2 power 6. 6C2 is 6 into 5. Take only 2 numbers, product of 2 numbers, 6 into 5 and denominator 2 into 1 and 2 power 6. 2 3's cancelled. So 3 into 5, 15. 15 by 2 power 6 is 64. So 15 by 64 is the answer. Next one, the probability of getting at least 2 heads when tossing a coin 3 times. Here coin is tossed 3 times. So n of S is 3 times. So 2 power 3 which is equal to 8. And n of A is getting at least 2 heads. Okay, a coin has 2 faces, head and tail. So here there are 3 times. Coin is tossed 3 times. So there are 3 chances to get a head. But here at least 2 heads. So we may get 3 heads also. But minimum 2 heads. So out of 3 we may get 2 heads. We can also get 3 heads. So that is also right. So in this type, in this cases, this type, we are taking in this way 3C2 plus 3C3 because out of 3 we may get to 2 heads or 3 heads because at least 2 heads. So these two are correct. So in this type we are taking just adding of these two answers. And now P of A. So P of A represents the probability of getting at least 2 heads when tossing a coin 3 times. So P of A equal to N of A by N of S. So which is equal to 3C2 plus 3C3 by 2 cube which is equal to 8. And 3C2 is 3, 3C3 is 1. 4 by 8 which is equal to 1 by 2. So 1 by 2 is the answer. 3 dice are rolled. 3 dice are rolled. If the probability of getting different numbers on the 3 dice is P by Q, where P and Q are co-primes, then Q minus P is. Here 3 dice are rolled. 3 dice are rolled. So N of S. Number of points in sample space is 6. Each face of each die has 6 faces. So like that there are 3 dice. So 6 into 6 into 6 is N of S. That is equal to 6 cube. And N of A is probability of getting different numbers on 3 dice. Different numbers on 3 dice. So on the first die, suppose if you get any number on the first die, on the second die we should not get the same number which is on the first die, which we get on the first die. So only the second die has 5 chances and the third die only 4 chances. So this is N of A. Therefore P of A probability of getting different numbers on the 3 dice is P of A equal to N of A by N of S. 6 into 5 into 4 by 6 cube. 6 cube is 6 into 6 into 6. 1 6 is cancelled and 2 3's, 2 3's. So 5 by 9. But it is given P by Q. So P is 5 and Q is 9. Therefore, the question is Q minus P. So Q minus P is Q is 9, P is 5. So 9 minus 5, 4 is the answer. If two sections of strengths 30 and 45 are formed from 75 students, so totally there are 75 students and there are two sections, and first section has 30 students and second section has 45 students who are admitted in a school, then the probability that two particular students are always together in the same section. That means they can go to the first section. Out of 30 students, they may be in the first section or both should be in the second section. So this can be done in two ways. So here n of s equal to out of 75 students, we selected 2 students. 75 C2 is n of s, and n of a is out of 30 in the first section, they may go to the first section. So 30 C2, or we can done in the second way, that is out of 45 students, okay, they may go to the second section also. So 45 C2. So this can be done in two ways. So we should add those two ways. Okay, therefore probability of two particular students are always together in the same section is n of a by n of s, 30 C2 plus 45 C2, and denominator n of s is 75 C2. 30 C2 is 30 into 29 and denominator 2 into 1, plus 45 into 44, denominator 2 into 1, and 75 into 74, 2 into 1. So 2 into 1 can be cancelled throughout. So then 30 into 29, we may cancel this one. 15 into 29 we can write. So that is 435, plus here also you can cancel with 44. So 45 into 24, 990, and denominator 237. 75 into 37, 2775. So 1425 by 2775. So the answer is 19 by 37. So 19 by 37. If two numbers a and b are chosen from the set of integers 1 to 39, so there are totally 39 numbers 1 to 39. So out of these 39 numbers, 39 integers, we are taking 2. Okay, and those 2 are named with a and b. Then the probability that those numbers satisfy the equation. The equation is 7a minus 9b equal to 0. What should be a and b out of 39 integers? First 39 integers. Okay, 7 into, the equation is 7a, 9b equal to 0. Okay, a must be 9 in the first case, minus 9 into 7. Okay, if you multiply 7 into 9 minus 9 into 7, it is 0. Okay, in the same way, all the multiples we can take. 7 into 9 2s are 18. 9 into 7 2s are 14. So this is also 0. Okay, here we multiplied this equation with 2. Now we can multiply this equation with 3. So multiplied by 3 gives 7 into 9 3s 27 and 7 3s 21. So this is another pair to get 0. We can also multiply with 4 and 9 4s 36. And minus 9 into 7 4s 28 equal to 0. We can't take, if you multiply with 5, we will get 45. But it is not there in our list. It is up to 39 only. So this is the end. So out of 39 integers, we are choosing only 2. So n of s equal to 39 C2. And n of a equal to 4 pairs. So what are those 4 pairs? A equal to, those pairs are 9 comma 7, 18 comma 14, 27 comma 21, 36 comma 28. These are the 4 pairs. So n of a equal to 4. Therefore P of a equal to probability that those numbers satisfy the above equation. P of a equal to n of a by n of s. N of a is 4 and n of s is 39 C2. So 4 by 39 C2. 39 into 38 by 2 into 1. So 2 we can cancel 2 ones and 2 nines. So 4 by 741 is the answer. 4 by 741. Card is drawn at random from a pocket of 100 cards. So totally there are 100 cards. So n of s equal to 100. There are 100 cards numbered 1 to 100. The probability of drawing a number which is a square is, so out of 100 we have the squares. 1 square we have, 2 square, 4 we have, 3 square, 4 square, 5 square, up to 10 square, because 10 square is 100. So we have numbers 1 to 100. So these are the squares we have in 1 to 100 cards. So how many are there? Totally n of a number of events number of 100. These are 10. 1 square, 1, 4, 9, 16. So all these numbers are there in our 100 cards. So those are the squares, perfect squares. So n of a equal to 10. Therefore probability of drawing a number which is a square is n of a by n of s, and n of a is 10, n of s is 100. So 1 by 10 is the answer. 1 by 10.